Hey mathematicians, I've got some examples in your math notebook 2.1, but I thought it'd be a good idea to show you explicitly a couple of examples that are straight from DeltaMath that you're going to be working on. So let's say you got this particular graph and it asked you for the domain. Well, we know that domain is your x values. So what I would need to do is look on my graph and look at the lowest x value on this continuous graph. So, and again, it's continuous because it's just got that one solid piece. That's that curve is like all one solid piece. So my smallest x value on the graph is -4. And then my largest part on the graph is +4. So because it's continuous and the graph goes all the way through here, it means that it's not just -4 and 4. We can't do what we did with a discrete relation because it was just individual coordinates. Well, this one includes all the points in between. So the domain is a lot more than just -4 and 4. It's all the coordinates in between there. And so there are two ways that you can do it. For this assignment, I would like you to do, because there's 20 problems on there, please do 10 problems using inequality notation. I'm going to show you what inequality notation is. And so because the domain is your x, and because it's between -4 and +4, you're going to write the inequality like this. You're going to say -4 is less than or equal to x, because x is, greater than or equal to -4, but it's less than or equal to +4. And that is the inequality way of showing that x is all the values that are between -4 and +4, because it's greater than or equal to -4, but it's less than or equal to +4. So that's how you would write it using inequality notation. So you can see down on the keyboard that you do have the inequality symbols. And there's another way that you can write it with interval notation. So for the purposes of this assignment, remember let me show you the range also really quickly in inequality notation while we're talking about this particular graph. So my bad. Didn't mean to change gears on you there for a second. So then the range, because we know that the range is the y, if I look at my lowest y value, you see that it's -9. So I'm going to do y is greater than or equal to -9, because -9 is the lowest point on the graph. And then the highest point on the graph is right here at 0. So between -9 and 0. So that means that y is greater than or equal to -9, but it's less than or equal to 0. So that's the inequality way of showing the domain and the range. So interval notation is the other way. So do 10 problems on DeltaMath where you do the inequality notation, okay? And DeltaMath will actually count either way you do the answer correct. So now I'm going to show you what I'd like the second 10 problems to be. Once you've gotten 10 right using inequality notation, then move to interval notation. And so what that would be is, because x is between -4 and 4, you just need to write a -4, comma 4, and then you put these hard square brackets around it. So that is the shorthand way of saying that the x values are in between -4 and +4. And then for the range, you would do something similar. You would do -9, comma 0, and then put the brackets on either side. So 10 problems where you do it like this, please. And then 10 problems where you do it like that. And I want to show you one more example, because this one's a little bit different. And the reason it's a little bit different is because you'll notice right here, instead of it being the closed circle that you had on both endpoints of the previous example, now you've got an open circle here instead. And what that means is that there's a hole in the graph right there. Like it's really just used as a landmark. So while you might say that your smallest x value is -7, it's not actually -7 because there is that hole there. So it's basically saying that everything bigger than -7 is included, but not -7 itself. So that impacts the way that we write the inequality notation a little bit. You still do -7, so if I'm doing the domain, so if I'm doing the domain, okay, sorry about that, guys. My pen was doing that weird goofy thing it does sometimes. Okay, so the domain, we're still going to write that -7, but instead of doing a less than or equal to symbol, because it's not actually equal to -7 because it's got that open hole, you're going to just use the less than symbol instead of the less than or equal to. But on this side, it does still have a filled in circle, which means it'll be less than or equal to 4. So it goes in between -7 and 4 still, but because this one has the open circle, you're gonna not make an equal to sign on that side of the inequality. Range still works the same way as well, but it's going to have a similar difference here. So again, my low point is down here at -9, but it's an open circle. So we're just going to use the less than symbol instead of the less than or equal to symbol. And then it goes up to 3, but it does have a filled in circle. So the range will be y is greater than -9, but it's less than or equal to 3. And then the interval notation is done a little bit differently too. And again, it's because of that open circle. So you're still going to put your interval for your domain as -7 and +4. And you're still going to put a hard bracket around that side because it does have the filled in circle. Basically, the hard bracket, the square bracket, is the math way of saying equal to. But because you have an open circle on this side, instead of the square bracket, you're going to use a parenthesis. And I know it doesn't look symmetrical. For those of us who like symmetry, it looks really kind of freaky and weird, but that is the correct way that you do it. And we would do the range the same way. So it would be -9 and +3. And you would have a hard bracket around the 3 because you do have a filled in circle there. But then you're going to use a parenthesis to go around the -9. And again, for the same reason, because you've got an open circle. So it's not actually technically equal to -9. It's just all the numbers that are -9 and above.